Welcome to our video on Oracle RAC interview questions and answers for experienced DBAs. In this video, we will cover a range of important topics related to Oracle Real Application Clusters, commonly known as RAC. Whether you're preparing for an interview or looking to enhance your knowledge, this video will provide valuable insights and answers to commonly asked questions. Let's dive in. Oracle RAC, or Real Application Clusters, is a database clustering technology that enables multiple instances to access a single database, providing high availability and scalability. It allows multiple computers to run Oracle RDBMS software simultaneously while accessing a single database, ensuring high availability, scalability, and redundancy. In the event of a server failure, the database remains available, and it can handle increased workloads by adding more servers to the cluster. Oracle RAC offers several benefits that make it a valuable choice for database management. Firstly, it enhances performance by distributing workloads and enabling parallel processing. This results in improved efficiency and faster query responses. Secondly, Oracle RAC provides increased availability by protecting against instance and node failures, ensuring continuous operation even if a server in the cluster fails. This minimizes downtime and enhances reliability. Additionally, Oracle RAC offers scalability by allowing the addition of nodes to the cluster, accommodating growing data and user demands. Its versatility enables support for various applications in different setups, making it a flexible and adaptable solution for diverse database requirements. Cache fusion in Oracle RAC is a mechanism that enables instances to share data blocks directly from each other's buffers without disk I/O, reducing latency and improving performance. This allows for efficient data sharing and access across multiple instances, enhancing the overall scalability and reliability of the Oracle RAC environment. Oracle RAC One Node is an option that allows a single node configuration within an Oracle RAC environment, providing the flexibility to easily convert it into a full multi-node cluster as needed. The Global Resource Directory, or GRD, in Oracle RAC, plays a crucial role in maintaining information about resource memberships and statuses across all nodes in the cluster. This coordination is essential for effectively managing cache fusion operations, ensuring efficient data sharing and consistency across the cluster. Automatic Storage Management, ASM, simplifies storage administration by managing disk redundancy and striping while seamlessly integrating with Oracle RAC for data distribution across the cluster without requiring manual intervention. This integration ensures efficient and reliable data distribution, enhancing the overall performance and availability of the Oracle RAC environment. SCAN, or Single Client Access Name, is a crucial feature in Oracle RAC that provides a single name for clients to access any database running in the environment. It simplifies client configuration and load balancing across nodes, ensuring optimal resource utilization and performance. Additionally, SCAN enhances high availability by automatically rerouting connection requests to surviving nodes in case of a node failure, ensuring continuous database access without manual intervention. VIP addresses play a crucial role in Oracle RAC by facilitating client connections to the primary instance on each node in the cluster. These addresses ensure continuous service availability, particularly during failover events, by redirecting client connections to the appropriate node. This helps maintain seamless operations and high availability within the Oracle RAC environment. Transparent Application Failover, TAF, in Oracle RAC enables client applications to automatically reconnect to another surviving instance in case of instance or node failure, providing seamless continuity without manual intervention. When a failure occurs, TAF automatically attempts to reconnect the session to another available instance in the RAC cluster. TAF supports two types of failover: session failover, which reconnects the session to another instance, and select failover, which replays the query that was in progress at the time of failure. The concept of Quorum Disk in relation to voting disks in Oracle RAC is crucial for maintaining cluster integrity and avoiding split-brain scenarios. The Quorum Disk contains metadata information that is used to make node membership decisions when network communication between nodes fails. This ensures that the cluster remains intact and operational even in the event of network failures, thereby preventing the risk of split-brain scenarios. Clusterware is a vital software component that plays a crucial role in managing resources within an Oracle RAC environment. It is responsible for managing node membership, monitoring resource availability, handling graceful shutdowns and starts, and facilitating communication among nodes to ensure high availability of services. A rolling upgrade involves upgrading one node at a time while the other nodes continue to provide service. This minimizes downtime and ensures continuous availability of the Oracle RAC infrastructure. During a rolling upgrade, the workload is redistributed to the remaining nodes to maintain performance. Careful planning and coordination are essential to ensure a smooth rolling upgrade process. In an Oracle RAC environment, monitoring performance metrics is crucial for optimizing performance. Key metrics to monitor include global cache utilization rates per instance or node, interconnect latency and bandwidth usage, and redo generation rates per instance. By closely monitoring these metrics, administrators can identify and address performance bottlenecks, ensuring efficient operation of the Oracle RAC environment. In an Oracle RAC setup, services are configured using the srvctl utility or Enterprise Manager. Administrators have the flexibility to manage services by adding or removing instances from service configurations. Additionally, service attributes such as preferred and available instances can be modified dynamically, providing a high level of control and adaptability within the Oracle RAC environment. Load balancing advisory feature functionality within an active grid infrastructure environment helps distribute workload across instances, improving resource utilization and response time. It uses performance metrics to determine the optimal instance for new connections, ensuring efficient distribution of workload across multiple instances running on separate physical servers. Load balancing advisory in Oracle RAC is enabled by default and can be fine-tuned using the cluster_database_instance view. Thresholds can be adjusted to suit specific workload patterns. Cache fusion technology in Oracle RAC reduces disk I/O latencies by allowing instances to share data blocks directly from their memory caches. This improves performance by eliminating the need to read data from disk when it is already available in another instance's cache. Additionally, it enhances scalability by enabling efficient data sharing across multiple instances without excessive disk I/O. In an Oracle RAC environment, employing strategies like ascending parallel upgrade deployments using rolling methodologies ensures the distribution of incoming traffic over surviving systems, reducing the impact of handling planned maintenance tasks. This approach gracefully executes end-to-end improvements in the architecture while keeping uptime intact and uninterrupted for end users. In this section, we will discuss configuring high availability in Oracle RAC. This involves implementing Oracle RAC for database clustering, using Oracle Data Guard for disaster recovery, and utilizing Oracle Clusterware for automatic failover. These measures are crucial for ensuring continuous availability and reliability of the database system, especially in mission-critical environments. By implementing these high availability features, organizations can minimize downtime and maintain seamless operations even in the event of hardware or software failures. To ensure optimal I/O performance in critical sustained database operations across multiple instances, it is essential to conduct I/O tuning assessments and review multipath architectures alongside driver updates based on manufacturer documentation standards. This can result in better throughput capacity and minimal latency punishments when complex transactional queries are concurrently processed across distributed nodes. It involves checking compatibility guidelines and adjusting configurations accordingly. To achieve a uniform distribution of blocks among rows with the same values and optimize DML operations on hotspot tables, it is essential to identify intense DML hotspot tables and enable hash partition tables. Implement data sharding based on hash functions and consider table partitioning strategies to ensure a uniform distribution of blocks among rows with the same values, thus optimizing DML operations on hotspot tables. To troubleshoot performance issues in an Oracle RAC environment, it's essential to identify high-load SQL statements, review cluster-related metrics, analyze buffer cache distribution, and check interconnect and network configurations. This comprehensive approach allows for pinpointing and addressing the root causes of performance bottlenecks, ensuring optimal operation of the Oracle RAC setup. To resolve a CRS resource failure in Oracle RAC, you would start by reviewing the Oracle Clusterware logs and verifying the resource status using CRSCTL commands. Then, you would attempt manual resource restarts and perform health checks on cluster nodes to identify any potential hardware or network issues. If a node evicts from an Oracle RAC cluster unexpectedly, the first step would be to check the Cluster Ready Services (CRS) and cluster logs for eviction reasons. It's important to review node alerts for system errors and verify the integrity of network connectivity. Additionally, examining CPU and memory usage patterns leading up to the eviction can provide valuable insights. Addressing any underlying hardware or software issues is crucial to resolving the problem. To troubleshoot network configuration problems affecting Oracle RAC communication, I would start by checking the network interface settings using ifconfig or ipconfig commands. Next, I would validate the VIP and scan address assignments and review the listener configurations for each node's connectivity details. Additionally, I would look for any firewall or routing issues that could be impacting the communication within the Oracle RAC environment. When facing cache fusion-related contention impacting Oracle RAC performance, it's crucial to take proactive steps to diagnose and mitigate the issue. Start by monitoring buffer busy waits and block transfer times using AWR reports. Analyze locks contention causing delays in block transfers among instances. Optimize SQL statements responsible for excessive data transfers. Consider resizing cache fusion buffers or adjusting instance parameters to alleviate the contention and enhance overall performance. To troubleshoot split-brain scenarios in an Oracle RAC cluster, I would first use the voting disk information to identify occurrences across nodes, also known as quorum loss. Then, I would verify ASM disk availability through OCR checks using the oifcfg command. Additionally, I would initiate CSS debug logging to capture fencing events causing split-brain situations before resolving them using CRSCTL commands. When dealing with recurring OCR corruptions impacting the stability of Oracle RAC, it is essential to follow a systematic approach to resolve this issue. Firstly, it is important to analyze the OCR backups to identify any changes leading up to the corruptions, particularly when encountering the CRS 02149 error. Additionally, checking the health of the disk using vendor tools such as the Smart Diagnostics utility, SmartTool, is crucial. It is also advisable to consider relocating the OCR files to a different shared storage device after ensuring backup consistency and proper permissions. To troubleshoot database hanging scenarios specific to Oracle RAC instances, I employ hang analyze reports when sessions are waiting on resources for excessively long periods, identify blocking chains disrupting resource access between instances, and address block recovery operations contributing to extended hangs. Additionally, I implement profiles file tuning modifications as needed. When troubleshooting ORA 29702 errors related to node reboot coordination in Oracle RAC environments, it's important to understand that this error usually occurs when one of the nodes fails or reboots while other nodes are still active. To troubleshoot this, you need to check the alert log of both the failing node and the cluster, as well as the CRS logs for rebooting messages. Ensure that all necessary services start properly. Thanks for watching. Oracle RAC interview questions and answers for experienced DBA.